In this session, we are going to discuss hydraulic system in tractors, which is the topic in Unit 1 of course Farm Tractors and Construction Equipments of 5th semester Automobile Engineering. These are the topics: hydraulic system of tractors, necessity, advantages, basic components, working principle of hydraulic system, types of hydraulic controls, position control, depth control, draft control, then MCQ, all that. So we shall go through the first topic. Hydraulic system. What is hydraulic system? So in this hydraulic system, we are using any mineral oil as the working medium. So this system we are going to discuss in the next classes, in the next session. Here we shall go through what is necessity of this hydraulic system in tractors. In this tractors, hydraulic system is necessary to raise, hold or lower the mounted or semi-mounted equipments. You know that to the tractor at the rear, these implements are mounted to that 3-point hitch. So that implements are to be raised and they have to be held in certain position and they have to be lowered. All that can be done by the hydraulic system only. Second one, to control the implement depth during field operations with minimum effort. So implement, it may be cultivator or it may be harrow, disc plow, moldboard flow, whatever it is, that implements depth can be controlled by using this hydraulic means. And also other necessities are to lift and dump the material. So in the trailer we carry some materials from one place to other place, so that may be soil or any agricultural things, manure, etc. It has to be lifted and it should be dumped at to one point. So that will be done by this hydraulic system by lifting the trailer of the tractor. Next, another necessity is to handle the implements. So many other, whatever the implements attached to the tractor, or they are mounted at the 3-point hitch. So there all that implements are handled by this hydraulic system only. The hydraulic system is also used for depth and draft control. Depth means depth of the implement. It may be plow or it may be cultivator. So depth of that implement can be controlled by this hydraulic means. So thereby we can control the draft. Draft means pulling of the tractor can be controlled. In some tractors, the wheels are driven by hydraulic system, that is hydraulic transmission system. So that is also another necessity of this hydraulic system. And also this hydraulic system reduce the driver's fatigue. So these are the some of the necessity of hydraulic system in tractors. Advantages of hydraulic system. The first advantage is it is easy and simple in design. So compared to the mechanical system, hydraulic system is the easy means of transmitting the power, and it can be controlled easily, and the power can be transmitted from one point to another point, and it can be controlled easily compared to the mechanical system because of the absence of levers, linkages, cables, gears, cams, shafts, and all that mechanical components are absent here. Just here we are using hydraulic components, they are connected by tubings. That's why this system is easy and simple in design. Next one, second one, the hydraulic system can be fitted anywhere and in any position. That means the components of the hydraulic system can be fitted at in the any available space of the machine, and they can be easily connected by tubings. So it has more flexibility for the design of machine. Next one is multiplication of force. In mechanical system, multiplication of force is done by using levers and gears. But in this case, multiplication of force is done by hydraulic means. This one is very simple, and we can multiply the force by hydraulic means easily. And another advantage of this hydraulic system is that the speed can be easily controlled. That means we can get number of speed ratios, n number, infinite number of speed ratios can be obtained by hydraulic means, which is not possible by mechanical means. We can get many number of speed ratios with hydraulic means. Next one, no wear and tear of the parts. In mechanical system, due to movement of linkages and mechanical parts, there will be more wear and tear, and it needs maintenance, and those parts are to be lubricated. In spite of better maintenance also, it is not possible to avoid wear and tear in mechanical system. But here there is no moving parts, and the oil itself lubricating the parts in hydraulic system. That's why there is no wear and tear of the parts in hydraulic system. Next one, compared to mechanical system, this one is cheaper to maintain. It can be maintained easily. When there is no wear and tear of parts, definitely it is cheaper to maintain. Heavy jobs can be done quickly with less effort. So naturally, when there is multiplication of force, we can do heavy jobs with less effort. Since there is no absence of moving parts, it has less noise. Again, easy to provide overload protection. Suppose if any member of the hydraulic system is overloaded, then there is a pressure relief valves are there. They relieve the excess pressure, and then excess oil is returned to the oil tank. Thereby it provides overload protection. Next, so hydraulic system works on Pascal's principle. So what is Pascal principle? This Pascal principle states that the pressure applied to the to an enclosed fluid, or to the fluid confined to the fluid in a confined volume, or to the fluid enclosed fluid, the pressure is transmitted uniformly in all directions. Pascal's law states that the pressure applied to an enclosed fluid is transmitted uniformly in all directions. Small force acting on small area can produce higher force on a surface of larger area. So, fluid in a confined volume, fluid in a closed container. So there should not be any leak, it should be a closed system. In that system, if we apply pressure at one point, whatever the pressure created inside the fluid is transmitted undiminished in all directions. That means inside that container you can check the pressure at anywhere, at any point the pressure remains same. But there should not be any leak. It should be the liquid in a confined volume. Then pressure applied at one point is transmitted equally in all directions. It can be illustrated by an example given here. So consider here there are two cylinders interconnected by a tube. The small cylinder has area A1, let it be 0.1 meter square. And next, consider another cylinder of larger area, of cross-sectional area A2, which is equal to 1 meter square. In those two cylinders there are two pistons fitted, and it is filled with some hydraulic fluid, hydraulic oil or mineral oil, whatever it is. Now apply a force F1, let it be 10 Newton. That force is applied on a smaller piston of cross-sectional area A1. We know that pressure created, let it be P, that pressure P equals F1 by A1. F1 is 10 Newton, F1 is 10 Newton and A1 equals 0.1 meter square. Force by area gives pressure. So 10 by 0.1, this gives rise to 100 Newton per meter square. such a pressure is developed inside the system. So 100 Newton per meter square pressure is developed inside this system. In this liquid, confined in a volume. So this whole thing is considered as a container. This whole thing is considered as a single container. This liquid is enclosed in a confined volume. Now we are applying a force F1 here, where the cross-sectional area is A1, pressure P equals F1 by A1, that is F1 is 10, A1 is 0.1, so 10 by 0.1 gives rise to 100 Newton per meter square pressure in this liquid. So according to Pascal principle, the pressure created here is P, that is 100 Newton per meter square. The same pressure is transmitted in all the directions. In this liquid, at any point you check the pressure, it will be 100 Newton per meter square only, because it has to obey that Pascal principle. Now that 100 Newton per meter square pressure is applied on this larger piston. So this larger piston has an area of 1 meter square. 1 meter square. So the pressure is 100 Newton per meter square and the area is 1 meter square. Therefore, this force F2 equals pressure into area P into A2. Then it gives P is 100, area is 100 into 1, that gives 100 newtons. So there will be upward force of 100 newtons we are going to get here. So this is a simple example. So by applying the force 10 Newton, we are getting here the pressure F1 by A1. Here it is P. Here also pressure is P. Therefore F1 divided by A1 equals F2 divided by A2, because pressure is same everywhere. In this cylinder, pressure is given by F1 by A1, that is equal to, in this case the pressure is given by, in this cylinder, F2 by A2. F1 by A1 equals F2 by A2. By simplifying that, we will get F2 by F1 equals A2 by A1. Therefore F2 equals A2 by A1 into F1. A2 by A1 into F1. So A2, F1 is 10, A2 is 1 divided by A1 is 0.1. So here also we are getting the upward force F2 is 100 Newton. Just you can see, imagine here the force applied effort is 10 Newton. With this we are going to lift a load of 100 Newton. That means force is multiplied 10 times. Like that, by increasing the area, we are going to get more and more leverage by hydraulic means. So based on this principle, the hydraulic lifts, hydraulic brakes, hydraulic press, all are working based on this principle only. So you can see here, as this obeys Pascal principle, everywhere pressure is P only, because applied pressure is P here. This P is due to F1 by A1. The same pressure is transmitted undiminishedly in all directions. Everywhere the pressure is P. That's why here, when the area is larger, we are going to get more force. Like that, force can be multiplied by using hydraulic means. So, multiple choice questions are given here. The question number 1, dash is used in a tractor to raise, hold or lower the equipments. Electrical system, mechanical system, hydraulic system, then electronic system. In all the nowadays tractors we are using hydraulic system only. So answer is hydraulic system. Second one is hydraulic control system operates 2-point linkage, 4-point linkage, 3-point linkage, none of the above. 3-point linkage. Next question, hydraulic system reduces the driver's fatigue. Thank you for watching this session. In the next session, we shall go through different components of the hydraulic system.